If you put ice cubes in your room, after the ice absorbs the room's heat and melts into water, and then you take it out of the room, the heat in the room is thus removed. This is actually the working principle of an air conditioner. Air conditioners essentially do not cool, they are just heat movers. The reason you feel cool in an air-conditioned room is that the heat in the room is moved out by the air conditioner, but the air conditioner uses something to move the heat. The medium for transferring heat is not water, but a more efficient refrigerant. Refrigerants are also called coolants, and the earliest and most famous type of refrigerant is Freon, which even became synonymous with refrigerants. Refrigerants have a series of thermodynamic advantages such as strong evaporation, condensation, and heat absorption capabilities, as well as being safe and stable. Now let's look at the entire process of how it works in an air conditioning system. The air conditioner mainly has 4 core components: the compressor, condenser, expansion valve, and evaporator. The compressor and condenser are part of the outdoor unit, while the expansion valve and evaporator are part of the indoor unit, with the refrigerant running through them via copper pipes. The refrigerant starts as a low-pressure gas with a temperature of about 5 to 10 degrees Celsius. It first enters the compressor, which, as the name suggests, is a machine that compresses the refrigerant. After being compressed, the volume of the refrigerant decreases, the pressure skyrockets, and the temperature instantly rises to 80 to 100 degrees Celsius or even higher. This is the physics knowledge we learned in school, which is that the pressure and temperature of a gas are directly proportional. When we compress a gas, its pressure and temperature both increase, and conversely, when we decrease the pressure, the temperature also decreases. If we compare the refrigerant to the blood of the air conditioning system, the compressor is the heart of the entire system and the most expensive and crucial component of the air conditioner. Early old-style air conditioners commonly use piston compressors, which operate like car engines, relying on pistons moving up and down to compress. Piston compressors were noisy and inefficient and have now been mostly phased out. High-end air conditioners now commonly use scroll compressors, which are not only efficient but also quiet. It has 2 spiral shell-like scroll plates. One is fixed and the other moves around it. After the gas is drawn in from the outside, it gets trapped between the 2 spiral lines. As the moving scroll rotates, the gas is gradually compressed towards the center, increasing in pressure, and finally expelled from the central exhaust port. After the compressor compresses the refrigerant into a high-pressure, high-temperature gas, the compressor's task is complete. The refrigerant is then sent to the condenser. The condenser is like a row of densely packed heat dissipation fins, with a fan blowing air over them, allowing the refrigerant to release heat and cool down. This causes the refrigerant gas, which is around 100 degrees Celsius, to slowly cool and gradually condense into a high-pressure liquid at a temperature of about 30 to 40 degrees Celsius. This may seem simple, but 2 principles of physics are used here. One is that heat always flows from a high temperature area to a low temperature area, and the greater the temperature difference, the more heat is conducted per unit of time. This is why the compressor compresses and heats it up. The other is that the boiling point of a liquid is related to pressure. Lower pressure means a lower boiling point, making it easier to evaporate. Conversely, higher pressure means a higher boiling point, making it easier to condense. The boiling point of the compressed refrigerant is also raised, so with just a little heat dissipation, it reaches its condensation temperature, condensing into a liquid and releasing heat. This is why you can feel hot air blowing when standing next to the outdoor unit. But note, the refrigerant is still under high pressure and is liquid, just not as hot. Next, the high-pressure refrigerant liquid flows through a place called the expansion valve via a pipeline, which is a pressure-reducing device for the refrigerant. Common types of expansion valves include capillary tubes, electronic expansion valves, and thermal expansion. Expansion valve. Let's take the common thermal expansion valve as an example. It has a suddenly narrowed valve opening with a needle valve in the middle controlling the flow of the refrigerant spray. As the passage narrows, the flow rate is restricted, and when the high-pressure refrigerant sprays through the valve opening, it instantly depressurizes and partially vaporizes. According to the relationship between pressure, temperature, and boiling point we just mentioned, a significant drop in pressure causes its temperature to plummet, instantly turning the liquid from 30 to 40 degrees Celsius into a low-temperature, low-pressure liquid gas mixture below 5 degrees Celsius, with a lower boiling point, making it easier to vaporize and absorb heat. Next, the refrigerant reaches the evaporator, which is also composed of a row of densely packed copper tubes filled with refrigerant and a fan. The fan blows indoor air over the evaporator, and the refrigerant begins to absorb the heat from the air, quietly evaporating from a liquid into a gas. The cool air you feel is actually the refreshing air left after the heat's been extracted. At this point, the refrigerant's temperature remains around 5 to 10 degrees Celsius, reverting to a low-temperature, low-pressure gas. Then it is sent back to the compressor to start a new cycle. So how does the air conditioner automatically control the temperature? This brings us back to the thermal expansion valve, which has a temperature sensing bulb installed at the evaporator outlet, filled with the same refrigerant. If the outlet temperature rises, the refrigerant in the sensing bulb vaporizes, causing the pressure to increase. The pressure is transmitted through the capillary tube to the top of the diaphragm, which will move downward. The pressure pushes the needle valve to open wider, thereby increasing the flow of the refrigerant, allowing the evaporator to absorb more heat. Conversely, the opposite is true. This forms a dynamic closed-loop control system, always keeping the evaporator sufficiently supplied with refrigerant without excess. The air conditioner artificially creates pressure and temperature differences using the refrigerant as a medium to transfer heat from indoors to outdoors. This is the working process and principle of the air conditioner. Do you understand?
If you enjoyed this video, don't forget to subscribe and hit the bell icon. And make sure to check out our next video. You're gonna love it.